What's up guys? Welcome to another edition of DevKit Weekly, where this week we'll be reviewing and raffling off this GS EVB AUD Bundle 1 GS, an audio evaluation board from GaN Systems. Holy DevKit, this is a lot of equipment. And that's because the GS EVB AUD Bundle 1-GS is, well, a bundle of two GaN Systems evaluation boards. One of the boards is the GS EVB Audio Amp 1-GS, which sports a 400 watt Class D audio amplifier, while the other features a 650 volt switch mode power supply with power factor correction that can be driven from a PFC or LLC controller. And being GaN Systems, both of these boards are powered by Gallium Nitride technology. So the Class D amplifier on the GS EVB AUD AMP 1-GS board uses the GaN Systems 100 volt GS61008P, a GaN-on-silicon power transistor that leverages enhancement-mode High-Electron Mobility Transistors, or eHEMTs, built on GaN Systems Island Technology, which optimizes cell layout. Because the eHEMT transistors provide a higher electron velocity than silicon or silicon carbide alternatives, this allows the GaN Systems transistors to produce unprecedented switching efficiencies of more than 96% at full load, at least in the reference design. The technology also contributes to reduced component count and a smaller overall size of the power subsystem in high-frequency switching devices like audio amps. The GS61008P 100 volt eHEMTs have gate drive requirements of 0 volts to 6 volts, are capable of handling very high switching frequencies above 10 megahertz, support both bidirectional flow and zero reverse recovery loss, and are manufactured in GaN PX packaging that ensures thermal resistance and low inductance in high-density power use cases. The GaN transistors on the Class D audio amplification board support both open and closed-loop topologies and are complemented by an LM5113 half-bridge GaN driver from Texas Instruments. Elsewhere on the board, you'll find a 24-bit Renesas D2 audio digital control processor that runs at 300 megahertz. The digital control processor also includes DSP features, integrated hardware accelerators, and a PWM modulation engine that can handle switching control and fault recovery tasks. Since these are conducted in dedicated hardware blocks, the MCU only uses 25% of its available MIPS, which frees up tons of other resources for tasks like UI functionality, low frequency control, and just general housekeeping. The board is capable of achieving 200 watts per channel into 8 ohms, 300 watts per channel into 4 ohms, and 400 watts of continuous output power. Power can even be scaled with the proper thermal management mechanisms, and one other pretty cool thing to note is if you implement the reference design in an open loop architecture and tightly control the dead bang timing, near closed loop true harmonic distortion performance can be achieved. Now, if you take a closer look, you'll find a bunch of goodies spread around the PCB, like optical and coaxial SPDIF ports, a master volume switch, stereo and analog interfaces, an auxiliary stereo analog interface, output filters, power supply connectors, audio output channels, and the dual GaN Systems power stages, as well as control switches up here that let prototypers jump back and forth between those open and closed loop configurations in a snap. Now, the other board, the GS EVB AUD SMPS 1-GS, is home to the 650 volt 22.5 amp GS66506T enhancement mode GaN-on-silicon power transistor. It's based on GaN Systems Easy Drive circuit, which can be adapted to any switching frequency, power level, or LLC or PFC controller to optimize system cost and ease of use. The GS66506T 650 volt eHEMTs have all the same features as the GS61008P device cousins and boast low total gate charge and output capacitance to provide low switching losses and high efficiency. Moving around the board, you can see a common mode AC line filter, AC line connector, plus minus HV split rail outputs, PFC inductor, PFC front end, and LLC half bridge. So putting this thing together is pretty simple. You just connect these two boards with these plus minus 32 VDC cables, then connect all of the requisite audio inputs and outputs. Then you can jump into Audio's Canvas 3 software development tool from Renesas and start amping up to your heart's content. So if you're not familiar with wide bandgap semiconductor materials like gallium nitride, what better way to start than with a GaN Systems audio evaluation board? Now this time you might want to hang on to your wallet if you're prototyping on a budget. The GaN Systems GS EVB AUD Bundle 1-GS costs a pretty penny, retailing for $995 from distributors like Mauser. But as we do every week, we will be giving away one of these for absolutely free to one of you, so long as you fill out the form that's linked to on the screen here, as well as in the description below. We'll even deliver it right to your door. So if you're super pumped about the future of power electronics, then you're certainly in the right place. Best of luck to you in this week's raffle, and we'll see you next week on DevKit Weekly.